Hello and welcome to another video of Vivek Learns. So in the last video we had solved two questions to find the GCD of the numbers and find the prime factors of the numbers. So now in this video let's continue the PepCoding Level 1 series and solve some more problems. So the next question that we have is the Pythagorean triplet. So we don't have the question for this, we directly have the solution here. Okay, problem link, let me click here. Saying 4 not 4, okay. So the question says that we have to take three numbers as input a, b and c, print true if they can form a Pythagorean triplet and false otherwise. So as we know, Pythagoras triplet is formed when a square plus b square is equal to c square, right? And how do we find a and b, and which is the c one, right? Which is the hypotenuse one. So we will take three numbers as input a, b and c, and then we have to find which is the largest one. Okay, so let's say I've considered for this case c is the largest one, and hence we do c square, and a and b can be side 1 and side 2, right? So these numbers are Pythagorean triplet only if a square plus b square is equal to c square. Okay, so the first thing that we need to do here is we need to find which is the largest side, right? Largest number of the three. So let me take the input here. A. Okay. So what we can do is if A is greater than B and E is greater than C, then hypo will be, and we have to initialize the sides as well, right? Side 1 and side 2. Let's name these number the sides like this. So hypo is equal to A then, right? B and side 2 is equal to C. Can have another else if statement here. And the last else part will have yep. And now we have to check if they are Pythagoras triplet or not. If right? So we are checking if hypotenuse square is equal to side 1 square plus side 2 square. If it is true, then we print true, and if it is false, we print false. Okay, so let's try to run this. Let's see for number 3, 4, and 5, right? True. Because 3 square is 9, 4 square is 16, 9 plus 16 is 25, which is 5 square. And if we give something like 3, 3, it prints false because 9 plus 9 is 18, and 18 is not equal to 16, right? So that was all about this problem. So next move to the next one. Okay, the curious case of Benjamin bulbs. Okay, you are given n number of bulbs. They are all switched off. A weird fluctuation in voltage hits the circuit n times. The first fluctuation, all the bubbles are toggled. In the second fluctuation, every second bulb is toggled. In the third fluctuation, every third bulb is toggled, and so on. You have to find which bulbs will be switched on after n fluctuations. Take as input a number n representing the number of bulbs. Print all the bulbs that will be on after the nth fluctuation. Okay, so let's try to understand this problem. So let's say we have six bulbs. One, two, three, four, five, six. Yes. And what happens is when there is first fluctuation, all the bulbs are on. 2, 3, 4, 5, 6. After the second fluctuation, what happens is the second bulbs are toggled. So 1, 0, 1, 0, 1, 0. Okay. After the next fluctuation, all the third bulbs will be toggled. Like this bulb will be toggled. So 1, 0, 0, 0, 1, 0, 1, 1, right? Only the third one, which is this one, and the sixth bulb will be toggled. After, like this is first fluctuation, second, third. For the fourth fluctuation, only the fourth bulb will be toggled. So it will be 1, 0, 0, 1, 1, 1, right? For the fifth fluctuation, fifth bulb will be toggled. And for the sixth fluctuation, only the sixth bulb will be toggled. So 1, 0, 0, 1, 0, 0. So this is for the fourth fluctuation. This is for the second fluctuation. This is for the third, fourth, fifth, and then sixth. And what pattern can we see here? We can see that only the perfect squares are are on at the last, right? So 1 is a perfect square, and then 4 is a perfect square. So only these bulbs are on at the last. Okay. So what is the logic that we will be following here is we will check if the number is perfect square or not. If the number is perfect square, then it will be on, right? And we have to print that number. Okay. So let us try to do that. So we take input a number, then we iterate till that number, and we check if it is perfect square or not. If it is perfect square, then we print it. Okay, we have to iterate till to start from 1, right? And we have to iterate till that number less than equal to that number, right? Let's consider a scenario for 9, for 4. Okay, so for 4 fluctuations, 1, 2, 3, 4. 1, 2, 3, 4. So only the first and the fourth will be on, right? So we have to check till that number from 1, right? Okay, so let's try to run this. Oh, and we have to print the square of the number, right? So for the 9 fluctuation, only first, fourth, and ninth will be on, right? Because those are the only perfect squares. So yeah, that was all for this problem. And from the next series, we'll be starting the patterns. So see you guys in the next video. Thank you.